Hi, how are you? Welcome to my channel Manohar Motivational Thoughts. Today I would like to explain structure of atom, 10th class 6th chapter in physical science textbook. So dear students, previously you may have watched various videos in my channel, but today I would like to concentrate on 10th class physical science important chapters and what are the important concepts which will be expected in exam point of view. So students, if you listen carefully until end of my video, you can understand every important concept in this chapter, structure of atom. So in the structure of atom, previously you have already learned about the subatomic particles which are present in an atom. So in 9th class already you have learned about different atomic models also. Thomson's atomic model, Bohr's atomic model and Rutherford's atomic model. So before going to this structure of atom complete details, once we recall our previous knowledge what we have learned in 9th class. So in an atom there are three fundamental particles. Those are electron, proton and neutron. Electron was discovered by J.J. Thomson and it is a negatively charged particle. Proton was discovered by Goldstein and it is a positively charged particle. Neutron was discovered by James Chadwick and it is a neutrally charged particle, means it is a zero charge. So these are the three fundamental particles present in an atom, and electrons are always revolve around the nucleus in particular orbits or shells. So once we recall what is Thomson's atomic model, Rutherford's model and Bohr's model, what we have learned in 9th class standard. So according to Thomson atomic model, he compared his atomic model with watermelon. So plum pudding model or watermelon model. So he compared the atom with cut surface of the watermelon, and all the red part is compared with the nucleus and the black seeds are compared with the electrons. So whenever you observe the cut surface of the watermelon, black seeds are compared with electrons, the red part is compared with the nucleus. So he explained that all the electrons are uniformly distributed or embedded in total mass of the atom. That total mass of atom is compared with the nucleus. So nucleus is nothing but the red part. Overall the mass of the atom is by the nucleus of an atom. That means the red part is present in the cut surface of the watermelon. So this is about the Thomson's atomic model. But later further experiments conducted by Rutherford, one of his student, not accepted, and many other scientists also not accepted because of the stability of the electrons. So electrons are highly mobile in nature, they have kinetic energy, they are always revolve around the nucleus and they are always take part in chemical reactions. So almost this is a invalid model. Next, Rutherford, Ernest Rutherford also proposed one atomic model. He compared his atomic model with solar system. In the solar system, how the planets are revolving around the nucleus, how the planets are revolving around the sun. In an atom also, center of the atom is compared with the nucleus and electrons are revolve around the nucleus. So this model is known as a planetary model. Here electrons are always revolve around the nucleus. But according to classical physics, whenever a particle revolve around the one center part, it will radiate its energy and it will lose energy and fall in the center of nucleus, then atom may be collapsed. So that is also one of the demerit. Later Niels Bohr proposed that electrons are revolving in the particular orbits or shells. These shells are known as stationary orbits or the energy levels. Whenever the electron is revolving around the nucleus in particular orbits, the electrons may lose their energy or they gain their energy. In order to electrons absorbs energy or emits energy, electron jump from lower energy level to higher energy level and higher energy level to lower energy level. So this is about the Bohr's model of atom. These all the three concepts we already previously learned in 9th standard. Now in this lesson we are going to learn about the all the atoms are similar or different. All the atoms are containing same kind of particles or different kind of particles. If you observe that carefully, all the elements like hydrogen, oxygen, nitrogen, fluorine, all the elements are almost having the similar type of particles like electrons, protons and neutrons. But all the atoms are same? No, all the atoms are not same, because they are different in their atomic numbers, they are different in their mass numbers. So if you observe carefully, hydrogen is having only 1 electron, but oxygen is having 8 electrons. Okay, so atomic number of hydrogen 1, so it is having only 1 electron, but oxygen 8 electrons, 8 protons. So here, based on the number of electrons, number of protons, every element is different in their properties also. So next, what is meant by spectrum is given. So what is a spectrum? Spectrum is nothing but, already we have learned in 5th lesson, whenever the white light is passing through a prism, or the splitting of white light into 7 colors is known as dispersion. So all a band of 7 colors, that means all the complete 7 colors like a Vibgyor or rainbow is known as a spectrum. A band of a collection of the 7 colors at a time is known as a spectrum. So in this lesson we are going to discuss about wave nature of light. What is wave nature of light? That means what is the nature of light? What is the nature of light? It is there actually, nature of light. So previously we have seen about the whenever you throw a stone in the still pond, how the water will travel? The water travel in the form of waves. So there transverse waves are appears. Whenever you throw a stone in the water will travel like this in the form of waves. And whenever the school bell rings, how the sound reaches to your ears, the sound also travel in the form of waves. Those are called longitudinal waves. So finally, nature of light, how the light travels in the different mediums, means how the light travel in vacuum, how the light travel in the air medium and water medium, glass medium. So light also travel in the form of electromagnetic waves. Light travel in the form of electromagnetic waves. So this electromagnetic wave is created by the vibration of a charge. Vibration of the charge it produces the changing in the electric field, and the changing in the electric field creates the changing in the magnetic field. So electric field, magnetic field travel perpendicular to each other, and suppose electric field is traveling in the horizontal and magnetic field will be in the perpendicular direction. So both travel perpendicular direction and creates the electromagnetic waves. So light need not to be travel in any medium. Light can travel in vacuum also. So light, what is the nature of light? Electromagnetic waves. Light is travel in the form of electromagnetic waves. The speed of light is 3 into 10 power of 8 meters per second in vacuum. So here electromagnetic wave, what are the characteristics of electromagnetic wave? Electromagnetic wave characteristics are wavelength and frequency. Wavelength and frequency. So here what is meant by wavelength? Wavelength is nothing but the distance between the two crusts or two troughs. That means here suppose this is a wave. The distance between this two crests, that means two upper the peaks of the wave, the two successive crests of the wave is known as that means these are called as troughs and these are called as troughs crest. The distance between the two successive waves is called as wavelength. Wavelength is denoted by a symbol lambda, and frequency is nothing but the number of waves produced in 1 second. That means it may be produced 100 waves, 200 waves in 1 second, then that is called as its frequency. Frequency is denoted with a nu symbol, nu. So there is a relation between the speed of light, wavelength and frequency, that is c is equal to nu lambda. C is equal to nu lambda. So here that means what is the wavelength is inverse proportional to the frequency. It is nothing but lambda is directly proportional to 1 by nu. Means here wavelength is more, frequency is less. So in the VIBGR, what is the visible spectrum? We know that where the wavelength is more, red color is having the highest wavelength and low frequency, and violet color is having the low wavelength and high frequency. So this is about the electromagnetic spectrum. What is electromagnetic spectrum? A vibrating charge creates the electric field. The changing in the electric field creates the changing in the magnetic field. Electric field and magnetic field both perpendicularly travel each other to produce the electromagnetic waves. So what is the nature of light? The light travel in the form of electromagnetic waves. So light can travel in vacuum also. The speed of the light is c is equal to 3 into 10 power of 8 meters per second. Now we will discuss about the what is electromagnetic spectrum. So generally electromagnetic waves have the wide variety of frequencies and wide variety of wavelengths. Means just imagine that in our class, if you write exam like FA1 or SA1, all are getting the same marks or all are getting the different marks. So if you observe that, we may get the from 0 marks to what is the highest mark. If it is FA 25 marks or it is out of SA 40 marks in physics, from 0 mark to the highest of 40 marks, all the different members will get the different types of marks. Same way in this electromagnetic spectrum also, the electromagnetic wave containing the different wavelengths, the entire range of the all wavelengths is known as electromagnetic spectrum. So finally electromagnetic will have wide variety range of the wavelengths. So here all the entire range of the wavelengths is known as electromagnetic spectrum. Means here if you observe carefully, almost 10 power minus 12 meters to almost 10 power 3 meters. So here wavelength ranges are different, wavelengths are there. Here cosmic rays are there, and gamma rays are there, alpha rays are there, and ultraviolet rays are there. Next visible rays are there, IR infrared rays are there, and radio waves are there, broadband waves are there. So here radar waves also are there. Here the highest wavelength to the lowest wavelength. So different wavelengths are there. So these all the entire range of the wavelengths is known as electromagnetic spectrum. But all the wavelengths we cannot see. The highest wavelength of ultraviolet rays we cannot see, gamma rays, cosmic rays also we cannot see, and lowest wavelength of the rays also we cannot see. But the visible spectrum at 700, almost 500 nanometers to 700 nanometers of visible spectrum region is there, that is called as the VIBGR. These VIBGR colors we can see. So here from violet to red color VIBGR. So violet, indigo, blue, green, yellow, orange, red. So here all the 7 colors, this collection of 7 colors is known as a spectrum. Already we have discussed that. So we can see only certain range of the particular wavelength colors, that is known as the VIBGYOR. So that is the visible spectrum. Whatever we are seeing, all the 7 colors, this is known as the visible spectrum. So finally, up to this is enough now. So now once I will recall you what we have discussed in this lesson. So we have discussed about the general atomic models what we have learned previously, Thomson's model, Rutherford's model, and Bohr's model of an atom. In this lesson, we have learned about the how the fundamental particles are arranged in an atom. Do all the atoms are same or different? Means all the atoms are not different based on their atomic number, number of electrons. What is meant by spectrum? What is the nature of light? And also what is meant by electromagnetic spectrum? So I hope you understand well. If you understand well, first you like my video and share to your friends. If you still not subscribe my channel, please subscribe my channel and continue to watch all the videos, continuation lesson and remaining topics also. Wish you all the best.